All right, I'm going to call today AP FRQ session 1 review. I'm going to go over a free response or two, and that's what we're looking at here. In this free response problem, this is a very good problem because this is the direction that the AP has gone to in the last couple of years, is they want you to find derivatives from tables and use derivatives that are in tables. They want you to look at graphs and find derivatives based on the graphs. And then they also want you to do analytical derivatives from equations. So here's this large free response. Now, normally a free response doesn't have that many sections, but as of last year with the virtual testing, they gave less problems to do, but the problems were more exhaustive. And so they really could test a lot from one problem. Because look at all the, usually, I've always told you there's A, B, and C, maybe A, B, C, and D. But because they only gave 3 problems last year, the problems were double the size. Okay? So that way you're on a roll. It's faster to do 6 or 7 parts of one stem than it is to do 2 different stems with 2 different sets of 3 or 4, because you've already done a lot of the work. So let's look at here. He's given us a function, 2 functions, f and g. So in the table, we know exactly the functional values. I'm sorry, it's not f and g, it's just g. Functional values of g at 1, 2, 3, 4, 5, 6 points. Those are the only points that we know information about. We have 6 points of the actual derivative at those places as well. Then function f, or h, is a curve made up of straight line segments. They've drawn it really well because you can tell that you've gone as far down as a -4, and you've gone as high as maybe 3.5. And your domain could be a -3.5 all the way to +3.5. And I think they do say somewhere that they are line segments. So that way you know that the derivative is constant from a certain point to a certain point. Then they gave you this really ugly function called f, sine of pi x plus natural log of 2 minus x. You see how much they've thrown in this problem. So to be really, to get a passing grade, you got to know a little bit of everything. He does say, let g be a strictly decreasing twice differentiable function. So we know whatever function this was, you could take the derivative at least twice, okay? Maybe not 3 times, because once you hit 0, you're done. You can't there's no sense of taking a derivative of 0. And he says it's strictly decreasing, means it's always getting lower. If you look at the functional values, 12, 10, 7, 4, 2, -2, it's constantly getting less, and you would never expect it to reverse back up and change the concavity. You wouldn't expect that. The table gives all the values of g. The table gives, it doesn't say all of it, it says gives values of g and g prime. And then there's where it says let h be a function whose graphs consisting of 3 line segments. Okay, wonderful. First part. Now, you may have to use parts of these again, so do a good job when you're working on them. Find the slope of the tangent line of f at x equals a -1. Well, f is using this function here. So you would literally start out with f prime of x, because you need to know what f prime of x. When you want to find a tangent line, you're looking for the slope of the tangent line, a point at the tangent line. So you got to find both those values. So f prime is your slope. of the tangent line. So let me do that derivative. Straight across, derivative of sine is cosine of pi x, but don't forget chain rule, multiply by pi. So I'm going to go right up front and put pi, cosine of pi x. And then natural log of u, this is u. Reminder, the derivative of natural log is du over u. So the derivative of 2 minus x is, it's going to be a negative 1. So I could go plus negative 1. I may just say minus 1. There's my du over 2 minus x. Du over u. Now I needed f prime at a 1. So that gives me pi times cosine of pi. And then minus, but plug in a 1 here. 2 minus 1 is 1, so minus 1 over 1 is just minus 1. Cosine of pi, we should all know, cosine of pi is a negative 1. So that gives me a negative 1 minus 1. I'm sorry, negative 1 times pi minus 1. So a negative pi minus 1. There's my slope of the tangent line. I also need to have the point of tangency, which would be f evaluated at 1. So I go back and look at my f again, and I'm going to do the same thing. Well, I can plug it in right now. Sine of 1 times pi, sine of pi, plus natural log of 2 minus 1 is 1. That's a natural log of 1. Sine of pi, we know, is 0. And natural log of 1 means e to what power is 1? No, e to what power is 1? Well, anything to the 0 power is 1. So that's 0. So I think it's 0. So then, as always, why did I do the whole thing? I thought I was finding the equation of the tangent line. Hello, I didn't need this right now. I might need it later. He just wanted to know the slope. All right, I found it. It's, I did too much. Negative pi minus 1. Use the equation of the tangent line. I knew I saw a tangent line somewhere, the equation of the tangent line, to the graph of g at x equals to 1. Well, that was f, so that didn't help me at all. G, remember, g comes from this table. So, as I was saying, I need the slope of the tangent line and the point of tangency at x equals to 1. Okay, so let's do the slope, m. That would be, since we're talking about g, that would be g prime at 1. So I go up to the table, and I find g prime at 1 is a negative 4. So that part's done. And the point of tangency, when x is 1, would be g of 1. I go up to the table, g of 1, 4. So then my equation of a tangent line is always y minus y1 equals the slope times x minus x1. Mind you, g prime of 1 is your slope. Your point of tangency is right here. I'm going to make it smaller. G prime of 1 is right here. My x1 is the x that I was using, which was 1. So that's going to give me y minus My point of tangency was 4. My slope was a negative 4. And x minus 1. I literally would leave that answer and not solve it for y. Because if you make a mistake, you're going to pay the price. That's an equation of the tangent line. Now I want the second derivative of h evaluated at -1. Where's h? H was the curve. See, we're hitting every single piece up here. So I'm looking at the second derivative at -1. -1 goes here. Well, the first derivative, h prime at 1, is simply the slope of this line segment, because he said there were 3 line segments. So a convenient place for me to figure that out would be go to that point. It's right on the corner of the box, and go right up to where I'm looking at. Looks to me like 1, 2, 1. That is a 2 over 1, which is 2. H double prime, I didn't even have to think that hard. The derivative of a constant would always be 0. So I didn't even have to think that hard. So he said they were line segments. So h double prime of -1. If you want to show the work, you can say h prime of -1 was 2. H double prime of -1 is 0. All right, now w is a new function. He introduced a fourth function called w, but it's defined by using a composition of g and h. And he wants to know w prime at 3. Well, before I can do w prime of 3, I should just do double prime of x first. So if this is w, and that's a quotient, he's testing you on the quotient rule. So it's the bottom, low-d high minus high-d low divided by low-low. So the bottom, h of x, times the derivative of the top, which is g prime of x, minus the top, which is g of x, times the derivative of the bottom, which is h prime of x, all over h of x squared. And so w prime at 3, I'm just going to rewrite that same thing, but put 3's in there. H of 3 times g prime of 3 minus g of 3 times h prime of 3 all over h of 3 squared. Now this could take us a while because we didn't use 3 for A, B, or C. We only used 1. So I got to go to H. H came from the graph. So I go to H of 3. And while I'm up here, since I know I'm going to use H of 3 and H prime of 3, maybe I'll just write it out up here in my scratch work. H of 3 would be, if I zoom in on this graph, nice and beautiful spot is 3. Well, while I'm there, what is h prime of 3? It would be the slope of that third segment. Since it's beautifully marked off with the beginning here, and I can use the exact point I'm looking at, looks like rise over run is a 1, and it's a positive direction. So I've gotten both of those. And what other function was I using? If I go back down, I'm also using a lot of g's. So why don't I go to G right now? And what do I identify? G of 3. G of 3 goes down to here is a negative 2. G prime of 3, while I'm down here, is a negative 3. Well, I maintain I have every value I need now to plug into that. Now I'm going to have to probably look back up in a minute. H of 3 was, did over there, was a 3. And G prime of 3 was a negative 3. So far I've got 3 times a negative 3 minus G of 3, I already forgot, was a negative 2. So I have a minus minus. Maybe I'll make that a plus. Because up there I said G prime of 3 was a negative 3. Oop, negative. Which one did I want? G or G prime? I wanted G. That was a negative 2. So minus minus. And then H prime of 3, back to the graph. H prime of 3 I did was a 1. So that's 2 times a 1. All divided by H of 3, and I'm going to square it. Well, H of 3 was the 3, so it's 3 squared is 9. Simplify. Negative 6 plus 2 over 9, negative 4 ninths. And I'm doing these on the fly, so if there's a mistake, you get points by being one of the first to let me know. Let K, another function, like we haven't done enough already, be defined by, okay, what do I see? K of x is a composite function. H of all of this. And he wants the derivative of K evaluated at 1. So if K is all of this, then K prime must be equal to H prime of f of x minus 2 chain rule times the derivative of the inside, f prime of x, and the derivative of negative 2 is 0. K prime of 1 will be H prime of, now inside is f of 1 minus 2 times f prime at 1. I sort of have some good news because I dealt with f of 1 and f prime of 1 in letter A. That was it. Yeah, we did it up here. We have both of them up there. Now, because I talked about the slope of the tangent line and I talked about the point of tangency. So I have them both worked out. Now, if A is wrong, you can still get full credit for this part I'm doing down at the bottom if I used wrong answers. Because I'm going to be docked right here, some points. But if I use my wrong answers down here, I will get it right. So I'm going to use my answers. I'm going to remind myself that f of 1 previously was considered to be f of 1. Where did I write f of 1? I know I did it somewhere. Oh, I did it somewhere. Oh, I did it underneath it, I think, when I was... no, all I wanted was slope back there. That's right. There's my f prime of 1. So I have that was negative pi minus 1. Let me put that down there then. F prime of 1 was a negative pi minus 1. F of 1, I was doing it and I didn't need to. Remember when I thought I needed the point of tangency? So I may have done it in there. Let's see. I wrote it in there. I wrote sine of pi plus natural log of 1. You just double check it. It would be sine of pi, and it would be natural log of 1. That was a negative 1 plus 0. I don't even think I did it right down here. So I wrote sine of pi, and I wrote a 0 here. Huh, interesting. Oh, it is 0. Never mind. I was thinking of cosine. The sine on the x-axis is 0. So it is 0. Negative 1. No, 0 plus 0. So that's going to be 0. So let's plug in what I have. Will be h prime. F of 1 was 0. 0 minus 2 is a negative 2. And f prime of 1, I said, was negative pi minus 1. I'm not done. I need to evaluate h prime of a negative 2. Because f of 1 was 0. 0 minus 2 is negative 2. Where's h at? H is the curve. H of a negative 2 at least it's on my graph. It's a negative 3. And again, no money back guarantee. H prime of a negative 2 was this H graph at negative 2. We looked at it before. 1, 2, 1. It's a 2. So equals to 2 times the negative pi minus 1 from before. So I'm going to leave that answer. But if temptation is getting after you, then go ahead and... All right, last part. V of x is another function, is the inverse of g. Find v at a negative 2. Well, v derivative of v. So if we're looking at negative 2 of v, that ordered pair was related to g, so up to the g graph. I'm looking at the negative 2, and that flips to the 3. So that point was negative 2, 3, but on g, it's 3, negative 2. Okay, because the inverse, we flip the x and the y. If you recall that when we have a graph and we talk about the y equals to x line, that when we draw the inverse, it is a reflection over the y equals x line. So what happens is the x's and y's flip when I talk about point 2, 1, maybe. It's 1, 2 for the reflection. So anyway, and the slope. So we're looking at, we want the derivative g, why is it not writing again? G inverse of a 1, no, it was not 1, it was of G inverse of, because G inverse is V, so V prime is G inverse at -2 is equal to 1 over G of the 3, right here, because this was on G. So G inverse, study the derivative of G at 3, and I go back up. G at 3, the derivative is a -3. So I gotta flip that, -1/3. Okay. Now the second problem, call this number 2. We have f, g, and h are twice differentiable functions. We know g of 5 is connected to h of 5, which is a 1. So g of 5 and h of 5 are the same. The line y equals, here's just is a tangent line to the graph of g at x is 5. And at the graph of h, so at x is 5. So it's tangent to both of those graphs at 5. And the ordered pair is 5, 1 on both. That's why we got a 5, 1 here. That's why it's a tangent line. It's the same tangent line to both. Find g prime of 5. Well, g prime of 5. This is g prime of 5. It is the slope of g and of h at x equals to 5. So remember, y minus y1 equals the slope times x minus x1. So just by moving that over, we've got y minus 1 equals to a 5/3, -5/3, x minus 5. So the slope, g prime of 5, is -5/3. I don't know why. It's kind of weird to have two equations that have the same tangent line, but it can happen, you know. Let b be the function given by 2 times x squared times g. Write the expression for b prime of x, and then b prime at 5. B prime, product rule, that's two separate functions. The first times g prime of x plus the second g of x times 4x. This is b prime of x. B prime of 5 will be 2 times 5 squared times g prime of 5 plus g of 5 times 4 times 5. What a mess. Well, we know that g prime of 5 was the slope at 5, which we already identified that to be a -5/3. And we've already defined g of 5 is already a 1. So that would be, let's continue that. 2 times 25 is 50. G prime of 5, we've already identified that to be -5/3. Plus g of a 5, he identified it to be a 1. So that's just a 1 times 4 times 5 was 20, plus 20. So it's just an ugly problem. You can leave that answer. You don't have to finish it up because that's the numerical answer. It saves time, and I'll probably make a mistake. Because 5 times 5 is 25, 250. Then, yeah, I'm going to leave it. If it's wrong, let me know. Let W be, it's a quotient. And so he's just testing you on write an expression for w prime and w prime of 5. So w prime is the bottom times the derivative of the top, 3h prime of x minus 1, because it's just an x, minus the top, 3h prime of x minus x, the whole thing, times the derivative of the bottom, which is just going to be a 2. 2 plus 0, all over 2x plus 1 all squared. Low d high minus high d low. D low means derivative of the bottom over ho ho. Now, that looks fine, but let me do w prime of 5. This was just w prime of x. 2 times 5 is 10 plus 1 is 11. Now I need 3 times h prime at 5 minus 1. And that's, we have that up there. Minus 3 times, it was 3 times h of 5 minus 5 times 2 over 2 times 5 is 10 plus it's 11, 121. Still simplifying. H prime of 5 was that fraction we wrote as, I wrote, hopefully I'm right, negative 5/3. I'm still sticking with it. So, what was I doing here? I had an 11 times 3 times, oh, okay, h prime, I already forgot the fraction again. Oh, negative 5/3. The good news is that thirds cancel out that 3, so it's just a negative 5. So it's 11 times a negative 5 minus 1. That'd be a negative 6. Yeah, 3 times negative 5/3, negative 5, negative 6. Minus h of 5 and g of 5 were both 1. Is that correct? Yes. I'm double checking every time so I don't write it wrong. So that would be 11 times negative 6 minus 3 times 1 minus 5 negative 4 times that 2 over the 121. All right, it's coming together. Negative 66 minus 3 times 4 becomes plus, because I see an extra minus here. 3 times 4 is 12, times 2 is 24 over 121. And then 66 minus 24 is 42. That's a negative 42 out of 121. I'm going to leave it. I'm not going to try to simplify or reduce. I could have made a mistake anywhere in there. I could have picked up a calculator, but this problem, guys, was no calculator allowed. Find the tangent line to the graph of h at x is 5 to approximate a tangent line approximation. So h prime, he wants I need h prime, since I'm looking at the tangent line of h at 5, I need h prime at 5, and I need h of 5. Well, h prime of 5, we have, do we not? H prime of 5, this was the tangent line, yes, this is was the 5/3, negative 5/3. And h of 5 is still a 1. So this is the slope of the tangent line. This is the point of tangency. Y minus y1, that's my point of tangency, equals to the slope, that's my slope of the tangent, x minus x1, whatever x we're talking about, which is obviously 5. So y minus the point of tangency, h of 5 was 1, The slope was a negative 5/3 x minus 5. That's my tangent line. Since I have to use it to approximate the h at 4.8, because we're using that line to estimate that answer, I'm going to solve this for y equals to negative 5/3 times x minus 5 plus the 1. So y at 4.8, I'm not going to finish multiplying it through because it's too much work. I'm going to go negative 5/3 times 4.8 minus 5 plus 1. And do I really want to? I'll do the numerator, because that's a 40, 24, negative 24 over 3 minus, becomes plus 25/3 plus 1. Here I go. I guess I am doing it all. Negative, make sure 8 times 5 was 40. Carry the 4. Yeah, I think it's right. That's negative 49. Oh, yeah, thirds. Oh, that was a plus. Sorry. Wasn't this part a plus? So that's not a, this isn't right. Negative 24 plus 25 is 1. This is a third. Oh, I erased it again. So that's just going to be a 1/3 plus 1. That's going to be approximately the answer. This is approximate, remember? Approximate. Approximate. And so 1/3 plus 1 is 4/3. And last part. Let p be another function, and it's g of x plus f of 3 of x, given that p prime of 5 is 1/3, and f prime, find f prime of 1.5, or 15, sorry. Wow. I think I have to do p prime. That's going to be equal to g prime plus f prime of 3x, chain rule, times 3. So I'm looking for p prime, or f prime of 15. Well, I am using I guess p prime of 5 will be g prime of 5 plus f prime of 15 times 3, which is what I wanted. So let's plug everything I have. P prime of a negative 5, a 5 is a 1/3. G prime of 5. What's g prime of 5? G prime of 5 is back up here again. Wow, again, G prime of 5. G prime of 5 was the negative 5/3 again, because this was the graph of G and tangent line, so it's negative 5/3. How that keeps coming up? Negative 5/3 plus f is what I don't know. F prime of 15 I don't know, times 3. I just got to solve it. F prime of 15 equals, we had the 1/3, bring the 5/3 over, plus 5/3. Take that whole problem and divide it by the 3, will be 6/3, which is 2/3. 1/3 plus 5/3 is 6/3. That's 2/3. That's what I'm sticking with. Let's see, did I have another problem we could play with? Okay, let me lock it. I'm referring to this. No, lock it, rotation. There, okay. All right. This is starting a free response problem. This is the third one. Again, we have a table of data, and a large container of hot chocolate is being emptied by skating party guests. At time t is 0, there was 120 cups of hot chocolate in a large container. And the rate at which the hot chocolate is being removed from the container is modeled by the differential equation H, where H of t is measured in cups per minute. There it is right here. This is a rate. This is a graph of a derivative. It's the tracking the rate that the hot chocolate is being emptied for the first hour. See, 0 to 60. And then A, using the data in the table, approximate H prime of 25. H prime of 25 is not in the table. So I'm going to have to approximate it using the endpoints where 25 would be. Here's 25. We know 22, and we know 28, or 28 could be down here, whatever. Either way, we don't know at 25. So I'll use the tangent line, or the secant line between those 2 points to approximate the slope at 25. So H prime of 25 will be approximately y1, which is 63, minus, it doesn't matter which one is y1, y2, it doesn't matter which way you go, 63, so y2 minus y1, 7.1, over the x's, 28 minus 22. And I don't know if this was a calculator problem or not, but I think it would be a calculator problem. 6.1, that's a negative, or 6.3, negative 0.8, I think, over 28 minus into 6. So you could leave that, but you just need units. I'll clean it up a bit. That's negative 8 tenths, and that's a 1/6. So technically you could say that's negative 4/30. But it was a rate, so it was cups per minute. I believe that's what the derivative was, cups per minute. All right, that's A of that. That was on that whole page. They didn't give me any more. Oh, bummer. Oh, that was it? Yeah, these are pieces. Mark rides his bike along a straight path. Mark's velocity can be modeled by the function v, ugly function, at meters per minute. Find Mark's acceleration. Well, we know that acceleration of t is the second derivative of position. Position, second derivative. But in this case, we already had velocity, which is your first derivative. So it's the derivative of the velocity. So I just have to do the derivative of v. So v prime of t would be, this is going to be a case of the product rule. Okay? So the first, t minus 1, times the derivative of e to the square root of t, which is e to the square root of t times the derivative of the square root of t, e to the u du. So e to the square root of t times 1/2 square roots of t. I remember that. How to do the derivative of the square root of x. It was 1/2 times 1/2 square root of x, because it becomes t to the negative 1, so it goes downstairs. Plus the second, which is e to the square root of t, times the derivative of t minus 1 is 1. So there's my derivative of v. But what do I want? I want it t is 4. So I'll write that out. V prime of t is t minus 1 times e square root of t times 1 over e square root of t plus e square root of t. Acceleration at 5 is v prime at 5, which is 5 minus 1 is 4. 4e to the square root of 5 times 1 over e to the square root of 5 plus e to the square root of 5. It'd been, oh my goodness. I was going to say, it'd be so much easier if it was 4. It was 4. Oh my goodness. So you're going to see me erase it all. Here goes. Erase that, erase that. Back up, back up, back up, back up, back up, back up. I'm only human. 4. A prime of 4 is equal v prime of 4. Oh, I was going to say, why are we leaving those ugly numbers? 4 minus 1 is 3. E to the square root of 4 is e squared divided by e squared, because 1 over e squared divided by e squared. Well, that wasn't very exciting. Plus e square root of 4 is squared. That cancels. Is 3 plus e squared. And last one I'm going to do. Consider this function. You got 2 cosine of x, and that's probably, this is f, and this is probably g. It's a parabola. Let d of x be the vertical distance between the two functions. Well, that must mean vertical distance. Let d of x be the vertical distance. Well, the distance changes, you know. It changes as you go. It gets smaller, and then it gets bigger, and then it gets smaller, then it gets real small, and then it gets bigger and bigger. So it's a weird function. That's interesting. Find the rate of change of d of x. Oh, okay. So basically, the d of x is top minus bottom. So d of x, and the top, well, the top was the parabola for a while, so it does change in different parts. So let's talk about at 2.5. Well, at 2.5, it's out here. So around this area, the top was the parabola. So parabola was 0.5 x squared minus 2 cosine of x. And since that's where I'm going to stick with it, d of 2.5. Well, I got to do d prime because it's changing. So I need to find d prime. Let me back up and not do the d of 2.5 just yet. D prime of x would be the derivative of this problem. That'll be 0.5 times 2 is 1. That's x. Derivative of cosine is negative sine. Negative negative is plus. Plus 2 sine of x. And now let me do the 2.5. D prime of 2.5 will be 2.5 plus 2 sine of 3.5. And I'm going to leave it like that answer because I didn't pick up a calculator. All right, that's enough for today.